In this video, we're going to take a look at graphing systems of inequalities. You've already been familiar with graphing inequalities. Now we're going to graph multiple inequalities on the same coordinate plane. Let's recall when we graph an inequality that we shade above. We shade above if we have a greater than or equal to symbol. We shade below, however, if it's a less than or a less than or equal to symbol. If our inequality is a greater than or equal to or a less than or equal to, we're going to have a solid line. And we have a solid line because we have this equal to as well, and we want to represent that visually. Dotted lines are missing that. It's a greater than or a less than, but no equal to. So this would be a dotted line versus a solid line. Couple things to keep in mind. We want to remember to solve for y in order to graph, and that's because that slope-intercept form, or y equals mx plus b, will be of help to me because I can start at my y-intercept and I can count based on my m or my slope. The other thing I want to remember is that if I multiply or divide by a negative, I have to flip that inequality sign. So that's one of the most common student mistakes that we want to prevent against. Let's take a look at our first example. In this example, the bottom inequality is already solved for y, but the top inequality is not. So let's solve that first. Negative 4x plus 2y is greater than 6. I'm going to solve that for y. I want to get it into slope-intercept form, or y equals mx plus b form. So when I add the 4x, I'm going to put the 4x in front of the 6, and that's because I want to keep that y equals mx plus b format. And lastly, divide by 2. And y is greater than 2x plus 3. To graph this, I start at my y-intercept, my 3. And from there, I count up my slope, up 2 into the right 1. And to help myself, I'm going to reverse that by going down 2 into the left 1. So that I can just get more points. I have a greater than symbol, which means that I'm going to have a dotted line because it's missing the underline. And since it's greater than, I'm going to shade above. So I'm just going to shade very lightly the above. And I know it's above because I'm standing at 3, and above 3 would be 4 instead of 2. So up above is this region here. I have not yet graphed that second inequality, so I'm going to do that now. I'm going to change colors. Okay, I'm going to start up at 4, and from there I'm going to count up 1 and to the right 1. If I don't see my slope in front of that x, it's assumed to be a 1. So up 1 and to the right 1, and then I'm going to reverse it. Down 1 and to the right 1, or excuse me, down 1 and to the left 1, just to give myself some extra points. Okay, this inequality is less than. It's still missing that or equal to, so it's also going to be a dotted line. And this time it's less than, so I want to be less than 4. My y-intercept is 4, 5 would be greater, less would be 3. So I'm going to shade everything that's below that blue. Okay, my final solution is the region that represents the overlap of both. I want to satisfy both inequalities at the same time. To do that, then, I pick the region that represents both red and blue. Well, to keep with my color scheme, red and blue when they overlap would give me purple, so I'm going to shade or highlight my final region. That final region is everything here that is below the blue inequality and above the red. Okay, this region here represents all of my solution sets. This is my solution region. any point that I would pick in this highlighted purple area would be a solution. So if I choose one, let's say here to the left 3 and down 1, if I pick this point here, -3, -1, it falls in my solution region. If I want to check this point, check to make sure that I have correctly graphed, I'm going to plug -3 in here, -1 in for the y. That's going to give me a value of 10. 10 is greater than 6, so it works for this one. And if I plug -3 again in for x, I get -3 plus 4, which is 1, and 1 compared to -1, -1 is less than 1, and so it works here as well. So this point is a solution along with any other point in that region. Let's do one more example. In our second example, we see a unique inequality, just a y is greater than or equal to -2. There's no x. Anytime we have a y compared to a number, greater than, less than, it doesn't matter, just y compared to a number, this is going to give me a horizontal line. If I had given you some type of x value, just x equals a number, or x is less than or greater than a number, that would have given me a vertical line. It's just important that we remember when we have those unique cases. So since I have y is greater than or equal to -2, I'm going to go to -2 on the y-axis, and I have a horizontal line. In this case, it's greater than or equal to. So my line is going to be solid. Okay, and since it's greater than, it's going to be everything above that line. This second inequality is not solved for y, so I'm going to solve for y now by minusing 3x from both sides. And since I'm dividing by a negative, the first thing I want to do is change this greater than sign to a less than. So I have y is less than 1/2 x. To graph this, and I'm going to change colors. To graph this, I'm going to start at 1/2 x, it's plus nothing. So I start at the origin, and from there I count up 1 and to the right 2, and I'll reverse that, down 1 and to the left 2, just to give myself some extra points. This is a less than, not equal to, so it's going to be a dotted line. And I want less than this, so less than 0 is -1, so it's everything below that blue line. Again, I want the region where these two shadings overlap, so that region happens to be here. So anything in this region is going to be my solution. Again, I can pick an ordered pair within here. Let's pick, for instance, 4, 0. So if I'm going to check the point, 4, 0, it falls in here. Therefore, right, is 0 greater than or equal to -2? Is my y value greater than or equal to -2? It is. And is 4 times 3 minus 6 times 0 greater than or equal to, or excuse me, just greater than 0? Well, 4 times 3 is 12 minus 0. 12 is greater than 0. And so 4, 0 checks, and so would any other point in this final region. In summary, it's important that you remember that you want to shade above, when to shade below, when to do a solid line, when to do a dotted line, and to not forget to flip that inequality if I divide by a negative. It's easiest to graph if I solve for y equals mx plus b, and my final answer is always the shaded region in which my two shadings overlap. So I've represented that in purple. I also encourage you to use colored pencils when you graph as well.